This is AP Calculus Self-Check 7.5 Solutions. So this one is actually pieces of other AP tests, so it doesn't actually add up to 9. The total for this one is going to be out of 7. So for part A, find the acceleration. Again, acceleration is going to be the derivative of velocity, vt prime, or v prime t. Shoot, thank you. And for the people watching the video, that sound in the background is the 3D printer. I apologize. So when I take the derivative of velocity, I find that that is equal to 2. So my final answer is that the acceleration is just always 2.
I was really scared of that because it was so easy. Yeah, I was like,
There is much rejoicing. All right. +1. I should do that in a different color.
If I just put 2, is that bad?
As long as you have a of t somewhere written on your paper, you'll get the point. All right, find all values of t for which the particle is at rest. Particle at rest, the definition of this is what?
When velocity is 0?
When velocity is 0, yeah, perfect. So velocity is 0, and here's our velocity, so set that function equal to 0. So 2t minus 4 is equal to 0. T is equal to 2, yeah?
I just plugged it in.
That's well, I mean, yeah, so we need to also explain our answer to get the other point. So if you have t equals 2, you get +1, but you also need to say particle at rest at t equals 2, and why? Because, and what is our reasoning? It's right here.
Where velocity is equal to 0.
Exactly, velocity equals 0. So the way that you score this one is if you said t equals 2, give yourself +1, and then you can do it down here too.
What if I said t equals 2 because v equals 0 at that time?
That's fine, yeah.
Wait, but I did my work like really different. Is that bad? Like I just plugged into for every single value.
That's fine, but you should.
Takes a long time.
It takes a long time, yeah. You waste a little bit of time, but you get the full points.
Okay.
All right, so part C, find the time at which the particle is farthest to the left. So farthest problems, and we're looking at left, not right. Usually we have a right problem, and we also have to explain our answer. So we have to set up a table here. So we'll have our time. We'll do start plus end. And that's gonna, or start plus end. What am I saying here? Start plus change. And that's gonna give us our end. All right, what values should we plug in for our time, girls?
All of them.
All of them? 0, 1, 2, 3, 4, 5,
0
6.
through 4.
0 through 4 because that's what it gives you.
Yeah, I did all of them. I just did 0.
So remember, you're really only plugging in critical values, and we found a critical value when we plugged in v equals 0.
Yeah, you did the 3.
So 2. So we do endpoints. Our endpoints are 0 and 4. So 0 and 4, and our only critical value is 2. You can plug in all of them, but the quickest way is just doing the critical values
So you
and
only
endpoints.
need start, end, and then C.
How do you
Exactly.
know? Oh, okay. How do you know those are the critical values? Like 4? Where did
So remember, this is our graph that we're looking at. Critical values are where it hits the x-axis, or where the velocity is equal to 0. So velocity is equal to 0 in part B. We did that. And there are shortcuts. Yesterday we saw that there's a shortcut when we're looking for farthest to the right. When we had so many critical values, we looked for places where we knew that we'd have a large positive area. But this is the easiest way to do this one.
4 then?
4 is the endpoint over here.
Oh.
Yeah, good question. And it says that the particle is at the origin when it starts at time equals 0. So our start for each of these is 0. And then the change is going to be the integral between 0 and whatever time we have, 0 to 0 for this one, of our velocity function, vt dt. We need a bar here too. And again, we need an integral between 0 and 2, velocity of time dt. You do need to show this work, that you're taking the integral. I know that you want to skip this step, but you do need to show it in order to get the points on the AP test. Vt dt. What is the integral of the velocity of time, by the way? Just the general antiderivative instead of doing the definite, or the no hard bounds or anything. So velocity of time, what is that?
Position time?
It is going to be position, I agree. Say it again, Carly.
T squared minus 4t.
T squared minus 4t. Perfect. So when I plug in 0, I'll have 0 minus 0. And by the way, since our beginning bound is always 0, when I plug in 0, it's always going to be 0. So we don't actually have to plug in 0. We really only need to plug in our upper bound. So this is going to be 0 plus 0, which is 0. Our upper bound is 2. 2 squared is 4. So 4 minus 8. 4 minus 8 is a negative 4. And when I plug in 4, 4 squared is 16, minus 16 to get 0. So farthest to the left, that is the position, but not the time of the particle when it's farthest to the left. And again, we're trying to find the time at which the particle is farthest to the left. So now we're going to go ahead and answer. So from this point, we know that the particle is farthest to the left, or farthest left, at time equals, and we have time equals 2.
Okay, I got time equals 2, but I did it wrong.
You did it
I did
wrong?
the whole graph thing, but I plugged all of them in, and I got -2 instead of -4. But that was my most negative number, so I said t equals 2.
Yeah, that's what you have to do. This is the quicker way of doing it, but you need to at least show that you did the integral. Did you do the integral?
Yeah.
Like she just
By finding
didn't
the
get
position?
right end number.
Yeah, I just didn't get the right.
You didn't get -4?
No, I got -2.
I don't think you'll get the points then, because this is everything right here is 1 point. You have to show your work here to get +1. If you have your start here, all of these starts at 0, your initial condition, give yourself +1. And if you have your explanation, it's farthest to the left at time equals 2, give yourself
What if I said
+1.
t equals 2 because the number is
I
the
got
smallest?
That's, yeah, give yourself +1.
I've never gotten this many points on a homework.
All right, so far we're up to,
Position is -4. Is that not enough?
no, you can't have position because asking for time. You can't get the point.
No, like I said, the particle is farthest left at t equals 2 because its position is -4.
That's fine, yes.
Yes.
So you get that 1 point here, but you need to make sure you show your work also to get this point.
Yeah.
All right, on to part D. Are there questions before I move on?
No, I'm just
Kaylin, off your phone.
I think I should get a point for
Whatever.
Kaylin,
Me too.
off your phone, thank you. Okay, so part D. Write but do not evaluate. So total distance traveled, what is that going to be? The integral from 0 to 2 of what?
The absolute value.
Ah, there it is. Good job. Absolute value of
Can we
VT.
do absolute value?
DT.
Can we do this dance move? Ready? The absolute value. So we all remember.
I like this. I agree. Yes. We need to do that dance every time. All right, so there's a total of 1 plus 6, so a total of 7.
Wait,
No.
this one got 6.
Shout out scores. What did we get?
I got 5.
Good?
4. I'm just
4?
kidding, I got 6.
5?
I think I got 6.
Joy?
I didn't
Wow, you guys are doing awesome. Good job. All right, so let's go ahead and start on self-check 7.6.